Today we'll see how to distinguish an unboiled egg from a hard-boiled egg. As you can see, there's nothing to tell the two apart. But if I spin them,
you're spinning, and I'm spinning, and the Earth is spinning, and the sun is spinning, and the solar system is spinning. Everything is spinning. But why? Everything is moving, and the whole universe might actually be moving too. Everything is moving, and the whole universe might actually be moving too. Hey everybody, thank you for watching D-News today. I'm Trace. You might remember from our How Fast is the Universe Moving video that you are moving really fast right now. For example, the Earth is rotating around its axis at 1,040 miles an hour.
Our entire solar system races clockwise around the galactic center at about 792,000 kilometers per hour. Our whole galaxy is also moving through the universe. We know this because when the universe was very young, it was so hot, electrons and protons jumped around, and photons of light scattered constantly. They couldn't travel very far before scattering again, so the universe was opaque. The universe cooled just enough for electrons and protons to form hydrogen. Suddenly, abruptly, photons decoupled from this obstacle course and could travel relatively unencumbered. The universe became transparent to light.
Now, to the maths! Your 1,000 miles an hour, plus Earth's 66,000 miles an hour, plus our system's 550,000 miles an hour, plus the galaxy's 2.237 million miles an hour equals about 2.855 million miles per hour, or about 800 miles every second. That's mind-boggling and kind of incredible. Planets rotate. That's what they do, right? But then science comes along and is all like, why? And once you start thinking about it, it's actually pretty staggering.
Planets rotate. That's what they do, right? But then science comes along and is all like, why? And once you start thinking about it, it's actually pretty staggering.
Planets rotate. That's what they do, right? But then science comes along and is all like, why? And once you start thinking about it, it's actually pretty staggering.
So we need to somehow see the Earth, or see the clouds moving with the surface of the Earth, like the claim is, like I hear all the time, is that, you know, the atmosphere moves with the Earth. So we need to see that as well. And like I say, we know that the clouds are part of the atmosphere. And so let's look into this in this short video, and let's see if the claims match up what we see. As you know, science is a process of observing and seeing what is going on through observation. So let's do that.
how to tell the difference between an unboiled and a hard-boiled egg.
First of all, the Earth's orbit is slightly elliptical, so its speed varies throughout the year. But enough of all of this. Let's sit back and enjoy Earth's movement without trying to divide it up and name it. As a caveat, keep in mind that Earth's oceans and liquid insides and other celestial bodies are always pulling and tugging and sloshing around, minutely changing Earth's movements. Their effect is measurable, but difficult to notice at big scales and also don't look like much in the short term.
Yeah, the whole damn thing.
The reason we found these differences is quite simply because of the centre of gravity. Because the boiled egg is solid, its centre of gravity remains constant, whereas the raw egg has liquid inside, which means that as it turns around, the centre of gravity, and therefore its centre of weight, is constantly moving around, making things like spinning on the spot completely impossible. So there you have it. That's how you can find the difference between a raw and a boiled egg.
The Earth spins once per day, which means that if you live at the equator, the surface of the Earth with you on it is moving around 1,000 miles per hour to the east, relative to the center of the Earth. Even at 45 degrees latitude, the Earth's surface is moving 700 miles per hour to the east, so it kind of seems like it should be faster for airplanes to fly west. I mean, their destination is literally spinning towards them. At the same time, however, they are spinning away from their destination. When we say the Earth is going 1,000 miles per hour to the east, that means that the ground and airplanes on the ground and even the air above the ground are all also moving 1,000 miles per hour to the east. For an airplane to get anywhere, it has to start moving relative to the ground and through the air at something like 100 or so miles per hour. So when it flies east, it's actually moving 1,000 plus 100 miles an hour to the east. And when it flies west, it's actually moving 1,000 minus 100 miles an hour to the east. Yes, to go west, you go east, just slower than the Earth is going east.
The reason you're not clinging to the ground with fright right now is because, again, speed is relative. You are not feeling it because we're all on this supersonic journey jet together. Us and all the stars in the galaxy. How does that make you feel? Small? Tiny? Insignificant? Super amazing and important?
Unless you're within 10 or so miles of the poles, in which case a brisk westward walk will take you legitimately west. That said, planes do often take different amounts of time to fly the same route in different directions.
Now, another thing I want to say is that it's actually not even scientifically possible for gas to be moving like a solid. What's going to travel further, like a golf ball or a ping pong ball? Golf ball has a little bit more mass, and we can see the distances that that golf ball travels when somebody hits it from the tee off. And then we've got, a ball the same size, but it's a ping pong ball, and it's filled with air, and so it doesn't have as much mass. So is it going to travel as far as the golf ball? No, of course not. Scientifically impossible. And so the same theory holds to the atmosphere moving at the same speed as the Earth. It's just not feasible. And I've also heard the argument that, since it's a vacuum in outer space, that's why it's possible. No, it's not. They don't have the same inertia. So, here we got a video that is showing what the atmosphere is doing, and can you see how there's different directions that the air is moving? So the atmosphere here in this video is not moving with the surface of the Earth. If it was, those clouds would be above the houses, because that is the surface of the Earth. And yet we're seeing all kinds of different directions going on here. There's nothing in this video to suggest that the atmosphere is moving with the surface of the Earth. The weather systems are caused by the sun heating up some air and other air in the atmosphere cooling off. It's not caused by the Earth's rotation at all. It has nothing at all to do with the Earth's rotation. It has to do with temperature and the sun having heated up certain air masses, and other air masses have cooled off, and so it causes a difference in temperature, and that's what causes the circulation in the atmosphere. It has nothing to do with the Earth's rotation. There is no rotation.
You're spinning, and I'm spinning, and the Earth is spinning, and the sun is spinning, and the solar system is spinning. Everything is spinning. But why?